In this lesson, we will master the techniques for solving quadratic equations and inequalities. We'll cover factorization, completing the square, and the quadratic formula alongside the graphical interpretation of inequalities. These concepts form the bedrock of pure mathematics 1 and frequently appear in Cambridge 9709 papers, often as components of larger problems involving coordinate geometry, calculus, or functions. By the end of this session, you will be able to select the most efficient method for any quadratic and accurately define regions for inequalities, which is vital for securing top marks in your examinations. Our first method is solving by factorization. This method relies on the zero product property. If p times q equals 0, then either p equals 0 or q equals 0. Let's look at an example. Solve x squared minus 5x plus 6 equals 0. We need to find two numbers that multiply to 6 and add to minus 5. These numbers are minus 2 and minus 3. We can now factorize the expression into x minus 2 times x minus 3 equals 0. Setting each factor to 0, we find that x equals 2 or x equals 3. The most efficient way to solve a quadratic equation is often through factorization. This method relies fundamentally on the zero product property. The logic is simple. If the product of two expressions is 0, at least one of those expressions must be 0. By breaking a quadratic into two linear factors, we can solve for x by setting each factor to 0 individually. Let's look at an example. Solve x squared minus 5 times plus 6 equals 0. To factorize this, we look for two numbers that multiply to give the constant term, positive 6, and add to give the coefficient of x, which is negative 5. These numbers are negative 2 and negative 3. We rewrite the quadratic as a product of two linear brackets. Now, applying the zero product property, we set each bracket to 0. This gives us our final solutions, x equals 2 or x equals 3. In the exam, always check if a quadratic factorizes first, as it is much faster than using the formula. Today, we look at a core concept in pure mathematics 1. Completing the square is a powerful technique that transforms a quadratic into the form x plus p squared plus q equals 0. This is not just a method for solving. It is essential in the 9709 syllabus for finding the vertex of a parabola and for describing transformations of functions. The general form is x squared plus bx equals bracket x plus b over 2 squared minus bracket b over 2 squared. The reasoning is that we create a perfect square trinomial. We take half of the coefficient of x, square it, and then subtract it to maintain the equality. Let's solve an example step by step. Solve x squared plus 6x minus 7 equals 0. Half of 6 is 3. Bracket x plus 3 squared minus 3 squared minus 7 equals 0. We subtract 3 squared because that term was added inside the bracket. Now, simplify the constants. Bracket x plus 3 squared minus 16 equals 0. Move 16 to the other side to isolate the square. Bracket x plus 3 squared equals 16. Take the square root of both sides. Remember to include both the positive and negative roots. X plus 3 equals plus or minus 4. This leads to two equations, x plus 3 equals 4, or x plus 3 equals negative 4. Solving these gives x equals 1 or x equals negative 7. In Cambridge exams, if a question asks for the exact value or uses the phrase in the form where a and b are constants, completing the square is often the expected approach. When factorization is difficult or impossible, we use the quadratic formula. It provides a direct path to the roots for any quadratic in the standard form. ax squared plus bx plus c equals 0. X equals the fraction minus b plus or minus the square root of b squared minus 4ac, all over 2a. The most critical part of this formula is the expression under the square root, known as the discriminant, denoted by the Greek letter delta. The value of the discriminant determines the nature of the roots without us having to solve the entire equation. This is a very common topic in Paper 1. If the discriminant is positive, the square root yields a real number, giving us two different solutions. Graphically, the curve crosses the x-axis twice. If the discriminant is 0, the plus-minus part disappears. We have one unique solution, and the curve just touches the x-axis at its vertex. If the discriminant is negative, we cannot take the square root of a negative number within the real number system. The curve never touches or crosses the x-axis. Find the nature of roots for 2x squared minus 4x plus 5 equals 0. Here, a is 2, b is negative 4, and c is 5. Let's calculate delta. Delta equals negative 4 squared minus 4 times 2 times 5. Delta equals 16 minus 40 equals negative 24. Since delta is less than 0, this equation has no real roots. In exams, you'll often be asked to find a range of values for a constant k that ensures a specific number of roots. Always start by setting up an inequality with the discriminant. Solving a quadratic inequality requires more than just finding values for x. It requires identifying a region. The most reliable way to avoid mistakes is to use a graphical approach. To solve an inequality like a x squared plus bx plus c is greater than 0, first find the critical values by solving the quadratic equation as if it were equal to 0. These values tell us where the curve crosses the x-axis. Next, sketch the parabola. If the coefficient of x squared is positive, the parabola opens upwards. If it is negative, it opens downwards. Finally, look at the inequality sign. If we want the expression to be greater than 0, we look for the parts of the curve above the x-axis. If we want it to be less than 0, we look for the parts below the x-axis. Let's look at an example. Solve x squared minus 4x plus 3 is less than 0. Let's find the critical values first. Factorizing the quadratic gives us x minus 1 times x minus 3 equals 0. So our critical values are x equals 1 and x equals 3. Since the coefficient of x squared is positive 1, the curve is a U-shape. We are looking for where the expression is less than 0, meaning where the curve is below the x-axis. As you can see from the graph, the curve dips below the axis between x equals 1 and x equals 3. We express this as a single continuous inequality. 1 is less than x and x is less than 3. If the question asked for greater than 0, our answer would be the two separate regions, x is less than 1 or x is greater than 3. Let's apply these skills to a typical Cambridge 9709 past paper style question. The equation x squared plus kx plus 9 equals 0 has two distinct real roots. Find the set of values of k. In the exam, the phrase two distinct real roots is your immediate cue to use the discriminant. First, identify the coefficients. Here, a is 1, b is k, and c is 9. For two distinct real roots, the discriminant must be strictly greater than 0. We find the critical values by treating it as an equation. The square root of 36 gives us positive and negative 6. Now, we must be careful. This is a quadratic inequality in terms of k. Since k squared is positive, the parabola opens upwards. We want the regions where the curve is above the axis. Many students lose marks by writing this as a single inequality. Because the regions are separate, you must write them as two distinct inequalities. To secure an A star, you must avoid the pitfalls that catch out many candidates. The most frequent mistake is failing to handle negative signs correctly in the quadratic formula, especially when b is negative. If b equals negative 5, then minus b is positive 5. Always use brackets when substituting negative values into b squared minus 4ac to ensure the square becomes positive. When solving a quadratic inequality where the solution is in two separate parts, students often try to combine them. This is mathematically impossible. If the regions are separate on your graph, they must be written as two separate inequalities joined by the word or. Never divide both sides of an equation by x to simplify it. Consider the equation x squared equals 5 times. Dividing by x to get x equals 5 is incorrect. By dividing by x, you lose the solution x equals 0. Always rearrange to equals 0 and factorize instead. When taking the square root of both sides, such as in completing the square, forgetting the negative root will cost you half the marks for that question. Always write plus or minus immediately after taking the root. To maximize your marks in Pure Mathematics 1, keep these examiner insights in mind. If a question asks for exact values, do not use your calculator to provide a decimal approximation. Examiners are looking for answers in surd form or as fractions. This is a clear signal to use the quadratic formula or completing the square and leave the square root as it is. Cambridge examiners award M marks for a correct method even if your final answer is wrong. Always show your substitution into the discriminant or the quadratic formula. If you simply write down the final roots and they are incorrect, you will receive 0 marks. Showing the step where you set b squared minus 4ac greater than 0 secures the method mark. Even if the question does not explicitly ask for a sketch, draw 1 for every quadratic inequality. It takes 5 seconds and prevents the very common mistake of choosing the inside region when the outside region was required. If a quadratic looks easy to factorize, do it. If it does not, do not waste 3 minutes trying to find the factors. Jump straight to the formula. Time management is crucial for the A-level exam. It is time to test your understanding. Please pause the video now and attempt these 3 questions before we go through the solutions. Easy. Solve x squared minus 8x plus 15 equals 0 by factorization. Medium. Solve x squared plus 4x minus 2 equals 0 by completing the square. Give your answer in exact surd form. Hard. Find the set of values of p for which the line y equals px minus 5 does not intersect the curve y equals x squared minus 2x1. Take your time with the third question. Remember, no intersection means the resulting quadratic has no real roots. Pause the video now. Let us go through the step-by-step solutions to ensure you have mastered these techniques. For the first question, we look for 2 numbers that multiply to 15 and add to -8. These are -3 and -5. Setting each bracket to 0 gives our roots. For the second, we take half of 4, which is 2. We subtract the square of 2, then simplify. The exact surd form requires us to leave the answer with the square root of 6. For the hard question, we set the equations equal to each other to find intersection points. Rearranging to equals 0 gives us a quadratic where the x coefficient is -2 minus p. Does not intersect means the discriminant is less than 0. Solving the inequality for p gives the range between -6 and 2. To summarize the essential points from today's lesson, always check for factorization first as it is the most time-efficient method. Use the quadratic formula or completing the square for non-factorable equations, or when exact surd forms are required. The discriminant, b squared minus 4ac, is a vital tool for determining the nature of roots. Remember, greater than 0 for 2 roots, equal to 0 for 1 repeated root, and less than 0 for no real roots. Never solve a quadratic inequality without a sketch. The visual representation ensures you correctly identify whether the solution is a single interval or 2 separate regions. Show all your working, especially your substitutions. Avoid common traps like losing the negative root when taking square roots or incorrectly combining separate inequality regions.